Hi, today we're going to be looking at 2015 PAT paper and looking at question 9. So question 9 says, by sketching or otherwise, find all values the function y equals minus 8 over x squared minus 4 minus 3 can take, given that x can take any real value. So we're trying to consider, as x takes all values over the real line, the values y is allowed to take, this function is allowed to take. There's three important things you want to consider when doing a question like this, when sketching a graph. So number one will be asymptotes. You want to find the asymptotes of the graph, the values the function will tend towards but never actually achieve. You want to find the turning points. So these are minimums or maximums, points at which the derivative is 0. And you want to find the limits. So by that I mean, as x tends towards infinity or minus infinity, or towards a certain value, how does the function behave? So let's start by finding asymptotes. So what values are not allowed in the question? Well, the big thing to look out for is dividing by 0. So we have here an 8 over x squared minus 4 term in our function. And clearly, when this denominator is 0, we're going to have a problem. So we have x squared minus 4 cannot equal 0. So to find the values of the asymptotes, we need to solve x squared minus 4 equals 0. Well, that gives us x minus 2, x plus 2 equals 0, or x equals plus or minus 2. So we're going to have an asymptote at x equals plus or minus 2. These are going to be vertical asymptotes. Okay, so let's do the turning points. So to do this, we need to find the derivative and solve for that derivative being 0. So we have y equals minus 8 over x squared minus 4 minus 3, which can be written as minus 8 into x squared minus 4 to the power of minus 1, minus 3. Now let's differentiate this with respect to x. So clearly we're going to lose the constant term, minus 3 is going to disappear. Now, dy by dx. So as usual, we bring our power down from the top. So the minus 1 is going to come down and cancel with this minus here. And the minus 1 is going to go to a minus 2. So we're going to have 8 x squared minus 4 to the power of minus 2. However, we need to remember that when you differentiate a function within a function of a function, we must differentiate the inside bit as well. So we need to find the derivative of the inside bit. Well, the derivative of the inside bit, so d by dx of x squared minus 4, is simply 2x. So we're going to have that this is equal to, we need to multiply further by 2x. So this will simplify to give us 16x over x squared minus 4 all squared. Now we ask ourselves, when is that equal to 0? Well, clearly we can only have that when the top is 0. So when is 16x 0? Well, the only value of x that will give us that is x equals 0. So we have x equals 0 is a turning point. Now what is the value of the function at 8 equals 0? Plugging into our equation above, we get that y would equal minus 8 over 0 minus 4. So we have minus 8 over minus 4 gives us 2. 2 minus 3 gives us minus 1. So we're going to have y equals minus 1 at the turning point. We now want to consider how the function behaves as we take the limit as x tends to infinity or minus infinity. So our function was y equals minus 8 over x squared minus 4 minus 3. So let's start by considering the limit, this is number 3, as x tends to infinity. Well, as x tends to infinity, we're going to be getting this term getting very, very, very large on the bottom. So we have a constant number 8 divided by a very, very large number. So that's basically going to tend to 0. So we're going to have this term disappearing and we're left with just this term. So that means that as x tends to plus infinity, y will tend to minus 3. And we notice that it's going to tend to minus 3 from below. As this gets smaller and smaller and smaller, it's going to be minus 3 minus a very small number. But that very small number is still results in this being less than minus 3. To say it more clearly, we're going to have y equals minus 3 minus something, with the something getting smaller and smaller and smaller. So we're going to tend to minus 3 from below. And we notice here that if we take the limit as x tends to minus infinity, as we have a squared term in here, it's irrelevant if this is plus or minus. So in fact, the limit is going to be exactly the same. So now we have asymptotes at x as plus and minus 2. We have a turning point at 0, minus 1. And we have x tends to infinity, y tends to minus 3. In fact, plus or minus infinity. So we can now start to sketch our graph. So let's draw some axes on. Now, let's start with our asymptotes. So we know for x being plus or minus 2, the function is undefined. So we'll label these with dotted lines. And we know at this point here, 0 minus 1, we have a turning point. Now, what we also need to notice is that we actually have another asymptote that we haven't noticed. We have to spot that because the limit as x tends to plus or minus infinity is minus 3, we're going to have a horizontal asymptote at y equals minus 3. So the function will never actually reach y equals minus 3. So we can label that in as well. So this is the asymptote at y equals minus 3. This is x equals 2. And this is x equals minus 2. So let's start to fill in our function. So we're going to have the function tending towards minus 3 from below as x comes towards plus infinity. So we know on this side here, we're going to have this behaviour. Similarly, it tends towards minus 3 as x goes to minus infinity. So we have to have similar behaviour here. Now we know the function doesn't go below this line here, as we know it's above, and there's a turning point here. So we must have the function looking like this. So as x tends towards plus or minus 2, we have this denominator tending towards 0. So you have a number divided by 0, which is essentially infinity. So the function will tend towards infinity. So now we can look at this graph and read off the values y is allowed to take. So we see y can take any value from minus 1 or above, but does not take any values between minus 1 and minus 3. So that's our answer. So we can write down that in fact y is greater than or equal to minus 1 and y is less, strictly less than minus 3. And that's the answer to our question.